Thank you. Okay. We study addition, subtraction, multiplication, and no division. Division no is not defined in matrix, but it's defined one idea similar to division, but actually it's not division. And after, when you are strong to the operation with the matrix, you say, now I want to illustrate one new approach to solving system of equations, but in different way. Let me start addition. Suppose that we have addition, two matrices. Suppose that we have two matrices, the matrix capital A, normally the letter that we use for the matrix capital. 3, -7, 0, 1, 2, 3. And by the way, that matrix, the dimension is 2 by 3, no? 2 row, 3 column. And we have another matrix B, capital B, que is 5, -2, 8, -2, 0, and 2. And it's the same dimension. Therefore, when it's the same dimension, it's the only possibility you adding or subtracting A plus B. And this is super easy because you adding entry by entry. So you adding 3 plus 5A. So you take the element in the first row in the first column, and you adding when the analogous element in the first row and the first column. Okay, so 3 plus 5 is 8. -7 and -2 together is -9. 0 plus 8 is 8. 1 minus 2 is -1. 2 plus 0 is 2. And 3 plus 2 is 5. Boom. Easy, eh? And very important. To add or subtracting, I want to explain now. To matrix, we need. Can the matrix have the same dimension? See, it's different dimension? No, impossible. You try with the software that I want to illustrate in a few minutes. The software say, no, this is impossible. Okay? Now subtraction. Do you follow me? I'm A minus B, for example. No, A minus B is the same, but the only A minus B change the sign of the B. Because A is -2, because it's 3 minus 5, no? -2, -7, sorry, plus 2 is -5. 0 minus 8 is -8. 1 minus 2 is 3, no? It's 3, no? It's 3. It's 1 minus 2. It's 3. And 2 minus 0 is 2. And finally, 3 minus 2 is 1. See, the problem was I changed. Okay. It's easy, eh? It's easy. Addition and subtraction is elementary. And by the way, we can use in the software. So you guys, you need to be familiar with the GeoGebra and the manipulation of the matrices. Okay? Okay, one more thing. Multiplication by the scalar. Suppose. In the test I asked you 5A plus 3B, compute that. So who is 5 and who is 3? 5 and 3 is a scalar. A scalar means it's just one number. And when you multiply 5 times A, you multiply 1 by 1 entry by 5. So 5A is 15, -35, 0, 5, 10, and 15. And 3B, So you multiply everything, every element, every number inside the matrix by the scalar outside. This is 15 again. This is negative, no, see, yeah, negative 6, 24, wow, I make a mistake. Well, okay. Okay, don't worry, let's do it. 3 times is negative 6, is 0 and 6. And finally, the combination both matrix is 5A is plus, entonces addition, this is 30, no? 30, because 15 plus 15. This is negative 41. This is 24. This is negative 1. It's negative 1, no? Yeah, it's negative 1. So 5 minus 6, 10 plus 0 is 10, 21. Do you understand the idea? So the thing you need to understand so far is addition, subtraction, and multiplication by the scalar. Entonces, in the last problem, I combine multiplication by the scalar plus addition. Easy? Easy?
Yeah.
And we're doing by hand. But in the real life, no, we're using the software, of course. I want to show you, but I want to show you not now. Let's say multiplication. The multiplication is more complicated. Multiplication of matrix. Okay, the multiplication of matrix a little bit complicated because frequently having A times B, suppose A and B is two matrix, no equal B times A. Sometimes some case yes, pero no, the majority, in general no. The multiplication of the matrix is not commutative. You interchange, no, you get different answers. So what is the procedure? Suppose you have the matrix A, que is 2, negative 3, 1, negative 4, 7, 0. The dimension of that matrix 2 by 3, 2 row, 3 column. And the matrix B is negative 1, negative 6, 10, 8, 5, and negative 2. Suppose this information is given. Nice. The dimension of this matrix B is 3 by 2. The requirement to be to exist the multiplication is the matrix A is 2 by 3 times the matrix B is 3 by 2. Okay, this dimension must be the same. See, this is different. Entonces you say, no. It's impossible, the multiplication, professor. Okay, in conclusion, the number of columns in the first matrix, 1, 2, 3, 1, 2, 3, should be equal to the number of rows in the second matrix, 1, 2, 3. And the answer I want to call C, the dimension is 2 by 2. Where come from this 2 and this 2? This 2 is this 2. And this 2 is this 2. This is a rule. Okay? So you before to do any problem of the multiplication, you checking. See matching or no the dimension. Because you suppose that you don't match it, you put in the software, and the software say no. The dimension doesn't match it. Okay? And entonces you expect another matrix is C, que actually we have only 4 numbers because it's 2 by 2. 2 times 2 is 4. And how you find that? Well, C11, okay, let me call the matrix C. This matrix is formed by C11, C12, C21, and C22, 4 elements. I use a double subgroup. What means C11? C11 is the element located in the row 1, column 1. That the first number represents row, the second column represents column. C12 is row 1, column 2. Makes sense, right? Column 1, column 2, row 1, row 2. But instead of working row, column, you put 1, 1, so everyone in the world understands that the first subgroup indicates row and the second indicates column. Row 2, column 1, row 2, column 2. Okay? How you find that? I want to explain. You multiply the row 1 and the first matrix A, because the order is important. So it's A times B, not B times A. By the way, B times A is impossible. Look, B times A, B is 3 by 2. Multiplication A is 2 by 3. Yeah, it's possible. It's matching also. And the new matrix 3 by 3 is big matrix. But it's okay. How you determine C11? This guy. You multiply like you multiply the row 1 and column 1. How? C11 is equal 2 times negative 1 is negative 2. 3, negative 3, sorry, times 10 is negative 30. And 1 times 8 is positive 8. And the answer is negative 24. Okay, that's so far, but not here. Here, my matrix is negative 24. Then you multiply this times this, this times this, and this times this. This is a reason that the number of columns in the first matrix should be equal the number of rows in the second matrix. To determine C12, well, similar, you multiply now again the column 1 and the first matrix, but the column 2 of the second matrix. So it is 2 times negative 6 is negative 12. Negative 3 times 5 is negative 15. Positive 1 times negative 2 is negative 2. And the answer is negative 29. Everyone follow me? It's confusing or it's clear? Clear or confusing?
It's clear.
It's clear. Good, very good. But don't worry for the arithmetic, because I want to explain in detail now in the software. Okay, the important is the interpretation, the algorithm that you apply well. Okay, suppose now C21. C21 is the multiplication, the row 2 and the column 1. Then is negative 4 times negative 1 is positive 4. And positive 7 and 10 is 70. Positive 7. And 0 times is 0. 74. And finally, 22. 22 is row, using another color, gray color, this guy times this guy. So it's negative 4 times negative 6 is 24. 7 times 5 35. and 0 times negative 2 is 0, and this together is 59, and this is the multiplication matrix, 2 by 2. Got it? Got it? Look like long process. I know, and this I select super elementary, easy, the 2 by 2. We compute 4 elements. And a scenario is very, very long. That is the reason they're using software, right? O sea, it's not hard, but it's tedious. It's too long. And in too long process, everyone make a mistake. And one sign, and one multiplication, okay, I confusing. Okay, so now, let's try to do this multiplication in GeoGebra. Here. GeoGebra. Share. GeoGebra. I suppose que you watching the video for the last lecture and you are a little bit familiar with the GeoGebra. Yes or no? Guy, you need to practice. Okay? Do you see GeoGebra or no?
Yeah.
Okay.
We see.
So now I put in the spreadsheet part. I put the number. Okay, the number is 2. You press 2 in the keyboard. Tap. -3. Tap. 1. Tap. Enter, much better. -4. Tap. 7. Wait, no. Okay, now I make a mistake. -4. Tap. 7. Tap. 0. Enter. Not necessarily you need to write below. You can write, for example, here. Why not? -1. Type it in any place of the spreadsheet. 6. 10. 5. 8, no? 8. And negative. Okay, you let me know, guys, if I type it well or no. The same value at the beginning I put in the whiteboard. Yes or no? 2, -3, 1, -4. It's important to check it because I omit one sign or change one sign, you don't get the answer right. Never. And you select one by one the array of number and you right click in my mouse and you see this menu, pop menu, and you create what? A matrix. And default here in algebra is creating one matrix and the name is N1. If you want to rename, you click here, rename, and you put, okay, now my name is now N1 is A. Suppose. It's not necessary to do that. It's an option. Now you select the second. You select the second, exactly the same. Create matrix. Create matrix. And rename B. Capital B. Okay, now multiplication. Multiplication is in cast. In cast you copy. A times B. Time is the same in the keyboard and the number 8, chip 8 is times B. Press enter. Bam! -24, -29, 74, and 59 exactly the same. We compute by hand. Okay? Super good. No problema.
No problem.
So you know very well how we compute the multiplication to matrix. Don't worry for the arithmetic part. because the arithmetic part is sometimes complicated. No, you put it in algebra, you in the spreadsheet, you edit the number, you transfer to the algebra, you change the name if you want, and in the cast you are doing the operation that you need. The operation that you need. No problem. You understand very well this multiplication of the matrix. Now you say, Professor, you say a division. We have no, we have no division. We have inverse matrix. Okay, it's a little bit different idea. Let me show you inverse matrix. Let me explain by hand the idea behind inverse matrix. Okay. Whiteboard. Okay. Do you see whiteboard?
Yes. Yeah, we see it.
Okay. I want to explain now inverse matrix. Inverse matrix. Okay, inverse matrix is one matrix. So you have, suppose you have a matrix. It's given. Suppose one hypothetical example, 3, 5, 1, 2. So I don't want to complicate my life doing by hand 3 by 3, 4 by 4. No, 3 by 3 to 4 by 4 we are doing in the software. By hand 2 by 2 it's okay. It's okay. This is 2 by 2. So 2 requirement to the inverse matrix exists. The inverse matrix not always exists. But when they exist, it's because the matrix is square. Two by 2, 3 by 3, 4 by 4. Si es 2 by 3, es a rectangular matrix, no. The inverse matrix do not exist. Other thing, non-singular. You don't understand very well this idea now, because to understand this idea, you need to see another thing I don't cover so far, but I promise in a moment I come back to this idea. Que es non-singular is que the determinant is a new idea, determinant, que I want to discuss in detail after this. But unfortunately, the concept mixed together in that part. Okay, what is determinant? Determinant is another approach to see the matrix. Okay, normally you don't use in the square bracket. No, you use in the bar. Very, very similar to the actual value. But this is not actual value. This is determinant. And the rule to compute determinant 2 by 2 is clear. I want to explain now. In the lecture of the determinant, I want to explain in detail what's the meaning of that. Okay, you multiply that number, you multiply this number, and you put positive. Put positive, no, doesn't affect by the sign. So the sign stays the same. So 2 times 3 is 6. And you multiply this number, and you put extra negative. Entonces es negative 5. And the answer is 1, correct? Entonces, non-singular means que the determinant of the matrix is non-zero. Super. 2 conditions is given to find the determinant because the inverse matrix, sorry, because our original matrix is given is a square 2 by 2 and it's non-singular because the determinant associated with the matrix is 1, it's not 0. Entonces, the conclusion is the inverse matrix, the symbolic way to indicate inverse matrix is very, very similar to the inverse function. Inverse matrix is -1 exponent. Actually, this is not represent -1. This is no exponent. This is a symbolic way to indicate. This is synonymous. the notation to indicate inverse matrix. And how you find that? Well, in 2 by 2 is super easy. In 2 by 2 is super easy. What is the formula? The formula is in 3 by 3 and 4 by 4, no formulas. No, it's crazy. But I want to explain the idea. But in 2 by 2, that's the most important thing, is suppose you have a matrix ABC in general, ABCD. You compute the determinant. Determinant is A times D positive minus B times C. Okay, super. And you divide the matrix by this number, 1 over D. And the action that I'm doing inside it is you interchange A and D. You put D here and A here. And you B and C stay the same, but I change the sign. And when the situation happens, this is the inverse matrix. This is a shortcut to do super fast in 2 by 2, and 3 by 3, and 4 by 4. It's crazy. Okay, now in our specific example, I retake the specific example we started at the beginning. It's 3, 5, 1, 2, no? Okay, what's the inverse? Well, the determinant is 1. The determinant is 1. 1 over 1 is 1. Okay, so the inverse is 1 over 1. And this is A, and this is B, and this is C, and this is D, no? A ver? No, A, B, C, D. This is D. So basically, you interchange A and B. So now this is 2 here, and 3 here. B and C stay the same position, place, but you change the sign. Negative, negative. Done. This is inverse. Okay? I understand? But what is the importance of this? What is the application of this? Oh, let me explain now. The application is if you multiply, let's do it in both ways. You multiply A, the original A, time multiplication, A inverse, the answer is identity matrix in the same dimension. No, CS 2 by 2, CS 2 by 2, it's identity matrix 2 by 2. Okay, by the way, identity matrix 2 by 2 is 1, 1, 0, 0. No? You remember identity matrix, right? 2 by 2, 2 by 2. And likewise, you are doing the multiplication in this order, inverse matrix time, so you can pre-multiply or post-multiply, depending the position, left or right. You get surprise again identity matrix. This is the only possibility that the multiplication of the two matrices is the same. We have more scenario, but no, it's very, very weird. Let's do it to understand this. Suppose I multiply, the original matrix is 3, 5, 1, 2, time 2, negative 5, negative 1, and 3. Let me check and see matching on other dimensions. Of course, check matching because it's a square. And you expect another matrix is 2 by 2. And remember, this guy you obtain the multiplication 3 times 2 gets 6. And 5 times negative 1 gets negative 5. And 6 minus 5 is 1. The second, this is the multiplication first row, second column. Is negative 15 and positive 15 is 0. This one is 2 and negative 2, 0 again. And the last one is this times this is negative 5 plus 6 is 1. Do you see? Do you see? Do you understand or no?
Yes.
After I want to check everything in GeoGebra. Okay, this is just, the theoretical part, you are familiar, blah, blah, blah. But Always we are doing. Suppose I am doing in different order. Suppose I copy 2, -5, -1, 3, get inverse function, and the original is 3, 5, 1, 2. And multiplication again. 2 by 2, 2 by 2, everything is 2 by 2. 6 and -5, 1. 10 and -10 is 0. -3 positive 3 is 0. And -5 and 6 is 1. Boom, exactly the same. Identity 8. Okay, professor, I understand that, but what's the application of that? Well, no. Relax, wait for a moment. In a few minutes, I explain in detail the application. The application of that. Let's move on to GeoGebra to solve this problem. In the computer. Okay. And okay. Do you see now, GeoGebra?
Yeah.
Let me try to edit the original matrix is 3, 5. 3, 5. 3, tab, 5. Enter. 1, 2. This is my original matrix. I select. I create matrix. Boom. This guy, if you want rename or no, this is not important. I copy my piece of paper. This is M1. M1 is the original. Now, in the cast, you find the inverse. The command, no, here in cast. Sorry, cast. Here, this is the algebra. So the procedure is you edit the number and the spreadsheet. When you create the matrix, automatically it's transferred to the algebra. In the operation you are doing in cast. In cast you put invert. It's invert like that. Invert. A little bit weird. No inverse. Invert. Invert what? Matrix. What matrix? N1. And this is the answer. The answer is 2, -5, -1, and 3. Exactly we did behind. Yes or no? You see? You see?
Yeah, we see.
Okay. Now I want to do the multiplication in both directions of the original matrix is N1 times its inverse and the inverse times N1. And you see the answer is identity matrix. Let's do it. In case you type it N1 times invert of N1. Okay, now the answer is boom, identity matrix. In the opposite direction is invert N1 outside the parentheses multiplication N1. Again, identity matrix. You see? Don't worry for arithmetic. And the formula for the 3 by 3 and 4 by 4 and multiple dimension is extremely complicated. Or no formulas. Yeah, hay definition, but no formulas. Now, to find the inverse species. What is the application for the inverse? Well, let me try to find one good example to illustrate this idea. Okay. No, we have no example. No. Wait a second. Oh, we can solve it. System of equation using this new idea. Algebra of the matrix, and so on. Okay. Let's come back to the whiteboard. Let's come back to the whiteboard. Okay. Whiteboard. Okay, I want to erase everything. Do you see whiteboard?
Yes.
Okay.
Yeah.
Okay, suppose this example. Of course, this example I want to solve it using the software, no, because it's too heavy. Suppose I have x plus 2y plus 3z equal 4. Equation 1. X plus y plus z equal -5. Equation 2. And x minus 2z equal -6. Suppose that system. Entonces you in the previous class we write only one matrix, it's the augmented matrix. Okay, no, forget about the augmented matrix for a moment in this class. You write one matrix A gets formed only for the coefficients inside in front the variable 1, 2, 3, 1, 1, 1, and 1, 0, and -2. Remember, when the one variable is missing, you put 0, right? Because y is missing in this case. And this is 3 by 3. And this is 3 by 3 gets a square. Maybe we can find inverse matrix. Maybe. Okay, now you in order to take the right hand side number 4, -5, and -6, called B. And this is 4, -5, and -6. And this is the matrix, but it's like a column vector. And normally it's called a vector when at least one dimension is 1. It's 3 by 1 because we have 3 rows, 1, 2, 3, and 1 column. And this is a vector. And you have another vector that I call capital X. Now, who is capital X? It's weird. Es the column vector que es formed by X, Y, and Z, pero the original X, Y, and Z. This guy, X, Y, and Z. Entonces now in that moment, I want to rewrite this system in different way. You write like that. One matrix, big one, que es 1, 2, 3, 1, 1, 1, 1, 0, -2, que es 3 by 3, and you multiply this matrix, que es A, times capital X. Capital X is a variable, it's a matrix formed by variable X, Y, and Z. And this is equal to the vector B, que es a vector for -5 and -6. Okay, the only thing I did was write these equations, like equation and matrix 4. But no matrix, no, it's separate the number in front of the variable, and the right hand side is B, and the variable I call X, Y, and Z. This is basic. The only thing I did was write as a matrix. Now, how are you solving that? Well, fantastic. Pay attention now. You solve it like that. I create like an abstraction que A, X, and B is a number, but a number and multi-dimension. But let me check the matching for the dimension. This is 3 by 1. 3 row, 1 column, matching the dimension, good, it's possible multiplication, and the answer is 3 by 1. This 3 is this 3, and this 1 is this 1. The matching, perfect, the dimension. Now, suppose subtraction, capital A times capital X is equal to capital B. We are working in the world of the matrix. So it's capital, 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 capital. What is my goal? This is my goal. Variable, goal. Now I propose you pre-multiply this equation by A inverse. So you copy A inverse times A times capital X is equal A inverse times B. So the only thing I did was, it's similar to in algebra elementary, you'd have 2x equals 4 and you divide by 2, no? It's the same idea, but a multi-dimension. You have 3 equations, you have 40 equations, and you solve 40 equations and 1 formula. Now, I know very, very well that A inverse times A is identity matrix of the same dimension of the problem. In this case is 3 by 3 times capital X is equal A inverse times B. I know also that when you multiply identity matrix times any matrix, the answer is the same matrix, and identity working like a 1. You multiply, suppose you multiply 2 times 1, is 2. This one is identity matrix, but in 1 dimension, because it's a scalar, it's 1 by 1, 1 by 1. But same situation happens, you multiply by identity 3 by 3 or 4 by 4, you multiply any matrix time identity matrix, maybe pre-multiply or post-multiply, nothing happened, because working like a one big one of the dimension 3 by 3 maybe. This is equivalent, this is symbolic, no? You know that actually is something like that. 1, 1, 1, 0, 0, 0, 0, 0, 0. This is identity matrix 3 by 3. I put example 3 by 3 because our example is 3 by 3, but not always 3 by 3, depending on the problem, no? And this is a formula, guys. So the only thing I need to do for solving the system is, number 1, step 1, compute inverse matrix. And step 2, multiply inverse matrix times B. Okay, B, remember, is the vector, the column vector formed by the right hand side. And magically happen, okay, you have a vector X, Y, Z, is capital X, and you have 3 numbers, something, 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 and this is solution. X is this, Y is this, Z is this. Do you understand? Do you understand the idea?
Yeah.
Yes.
Let's do it. Now there's a moment to do. Let's do it. Okay. Let's do it now. Sure, here. I have a lot of paper on my desk. Okay. Let's do it, but no manually. No, hello. I'm doing so. Okay. My problem was, okay, here, over there. Okay, he's supposed to see Jojo, right? I copy here. I copy the original matrix. It was 1, 2, 3. 1, 2, 3. Okay. 1, 1, 1. Oh, no, 11. 1, 1, 1. And 1, 0. Oh, no, boy. D. And -2. This is my matrix A, que es 3 by 3, 9 elements. And B, suppose I type in here a 4, -5, and -6. Okay, ready. I select my matrix A. I create matrix. And this is the matrix M2. M2. Okay. I select this guy. Create matrix again. And this is the matrix M3. What is my formula? My formula is invert what? N2 multiplication N3, no? Press enter. Bang! So I get the vector. You see okay, we have three rows, 1 column, and therefore x is -22, y is +25, and z is negative. Do you see the power of this? Okay, now I come back to the whiteboard. When you multiply this guy, look, let me show you. When you multiply this guy, whiteboard. Okay, when you multiply the answer of that formula, que is capital X, and who is capital X? Capital X is a vector, letter X, letter Y, letter Z. The answer given is -22, +25, and +8. Therefore, I conclude that X is -22, Y +25, and Z is 8. End the story. This is my final answer. Do you understand very well or no? This is another approach. Remember, so far we studied 2 approaches. Approach number 1 we studied was create not 2 matrices, only one, augmented matrix, and you apply the Gauss-Jordan elimination method. Of course, it's too tedious, too long. Everything is long here because the system of equations is long, but it's doable, and you compute the solution. Another approach is this approach is the compute inverse matrix and multiplication by b, and you get a new vector, and this is x, y, and z. Let's do one more example and stop for today. Let's do one more example and stop for today. Okay. Now we have another approach that we study next week. Entonces now when we finish that, I go over the review at the beginning, everything, right? Okay, but it's important that you are familiar with the GeoGebra. Mr. Amore, do you definitely you can using the right click in your GeoGebra or no? Are you there or no? Are you sleeping, no? Amore? Amore? Amore. Okay, one more example. One more example. Suppose this example. X plus 2y plus 3z equal -9. Equation 1. x plus y plus z equal negative 12. Negative x plus y plus 2z equal negative 8. Equation 3. Remember, see, in the test, there are one question is like that, or two questions. You are doing solving using inverse matrix. Okay? Entonces, what is A? A is 1, 2, 3, 1, 1, 1, negative 1, 1, 2, 3 by 3. Who will be? B is negative 9, negative 12, and negative 8. 3 by 1. I need to compute A inverse first, and after multiplication, A inverse times B. Okay, let me try to write everything. I take this, find the inverse matrix. Okay, by the way, the inverse matrix is also 3 by 3, but a different value, no? Let's do it. So it's do by hand, and this is crazy in the software, right? So it's okay. 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 There you go. Do you see the algebra?
Yes.
Okay.
Yes.
Okay, I move on to this. I edit. Similar to this, but no. You can, if you want, you copy. Look, copy and paste. But it's not the same. It's 1, 2, 3, 1, 1, 1. This is negative 1 here. You change negative 1. Positive 1. And 2 positive, no negative. And this one is completely different number, but I copy paste only to keep the dimension and the position. It's negative 9. Is negative 12. Oh, what the hell? Negative 12. Negative 12. And negative 8. Now you select this. Right click. Create matrix. Okay, it's M4. M4. I need to remember this. I copied the piece of paper. So the A matrix in this example is called M4. Okay, now I select the second, create matrix M5. I copy. The B is 5, M5. But I need two answers. I need the inverse matrix alone. Look, I copy in gas. Invert matrix. I copy M4. Okay, enter. Okay, the inverse matrix, and this problem is I want to copy on the piece of paper. 1, negative 1, negative 1. Negative 3, 5, 2, 2, negative 3, negative 1. Okay, this is the inverse. Inverse of M4. Okay, so I want to copy in the whiteboard after. Now let's finish that part. This is the multiplication this time M5. Okay, so again I type in invert matrix of M5 time M5, no, M4, sorry, M4 time and 5. And the answer is 11, negative 49, and positive 26. It's the solution. Okay, I come back to the whiteboard. And the whiteboard, I write everything. I write. Okay, there you go. In the whiteboard, I write. The matrix is, the inverse matrix is 1, negative 1, negative 1, negative 3, 5, 2, 2, negative 3, and negative 1. Super. Now, the multiplication was a vector. Okay, the vector is 11, negative 49, and 26. Therefore, x is 11, y is negative 49, and z is 26. End of story. We finish. Do you understand very well this approach, inverse matrix application?
Yeah.
Okay, the rest of the time that we have, let me try to introduce the new approach, que is determinant. It's completely different, guys. Well, so far we studied 3 different methods for solving linear system of equations using matrices. Gauss-Jordan elimination, inverse matrix, now determinant. Determinant is the name of this guy, determinant. Actually, determinant I did a little bit before determinant. It's super easy. Determinant is suppose we have one determinant. Okay, suppose 1, 2 by 2. Easy, no big deal. Is 2, 3, 5, 6. And the rule for 2 by 2, okay, determinant is different. Let me explain the idea. Determinant is like a function. And you get the matrix. By the way, it's only applied for the square matrix. Two by two, 3 by 3, 4 by 4. Never is possible to apply determinant in rectangular. No, it's impossible. You put in the algebra, it say no, wrong. Mismatch dimension. Determinant is you associate this matrix with a number. And the number have a specific rule to find. And you need to respect the rule. Let me explain. You multiply that number times that number. Okay, 12. And positive. So positive means okay, you multiply and don't change the sign. It's 12. And you multiply this number, and you change the sign. When you go over, change the sign. So like a 1 extra negative 1 you have. And minus 15 is negative 3. And the answer may be positive, or maybe a negative, or maybe a 0, depending on the problem. This is the rule to compute determinant 2 by 2. That's easy, eh? Now 3 by 3 is a little bit more complicated. I want to explain by hand at least one example. And 4 by 4 is crazy. Nobody do by hand. No. But the most important is that you get a number, guys. And the inverse matrix, no, you get another matrix. Okay, and the determinant is you working with the matrix, but basically you compute numbers. Okay, let's do it. Suppose 3 by 3, this example. 1, 1, negative 2, negative 2, 4, negative 1, negative 3, 5, 5. This is 3 by 3. 3 by 3. 3 row, 3 column. Square. Good. We have 9 elements. 3 times 3 is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. Entonces we can expand this determinant. Let's do it by hand. The first time we do it by hand and check it with the calculator. You can take any row or any column. This is the beauty of this, to expand. Normally the people prefer take the first. So we navigate for the first. Not always is convenient to take the first, depending on the problem, no? But it's okay. Let's do it in the first example using the first. What means you navigate for this? This is me. Yeah, walking in that direction using the first column. So you take the first number, get 1. You copy here, and you compute the cofactor. Cofactor. What is the cofactor? The cofactor is a new determinant que is formed when you delete mentally the first column and the, so you take this number and you delete mentally this and this. And you have now 4, -1, 5, 5. Do you see this idea? That you delete mentally, so we are doing the first entry, the 1. I copy here, this one is this. You delete mentally, first row, first column, and you get the new determinant, that of course is smaller than the original, and you get that. And that's it, no. So I'm working for the second. And the second is 1, again, but actually it's -1. Why is -1, professor? Because the cofactor have sign, positive or negative. And that depends on the position of the cofactor. There are many rules to memorize this. However, in my opinion, the best way is, if this is a matrix, the first is positive, the second is negative, alternating positive, negative, positive, negative, positive, negative, and positive. This is one mnemonic device. Another mnemonic device is, you see, for example, we are doing in this guy. Why is the reason that this is positive? Because it's located in the first row in the first column. And 1 plus 1 is 2, and see, it's even number is positive. And this guy is negative because it's located in the first row, second column. It's 3. And 3 is odd number. When you adding the number of column and the number of row, CS even is positive, CS odd is negative. That is the reason the negative. Negative multiplied by something. And now you delete this guy and this guy. And stay alive, -2, -1, -3, and 5. Do you see it or no? And finally, the last guy, que es -2. According to the position is positive, pero actually the coefficient is negative, so it's -2. And you have another determinant que es obtaining when you delete mentally this guy and this guy. So it's -4, -2, sorry, 4, -3, and 5. Do you understand the idea or no? What's confused? I finish? No, of course, no. I need to finish. Compute the 2 by 2 determinant, no? And that's a 1 is nothing. You multiply this and this, it's 20. 20, 20, 20, 20. This is 20. And this is 5, no? Pero es negative, no? Pero negative, double negative become positive, entonces es positive 5. Minus. This and this is -10. And this is, well, negative, negative, negative. 3 negative. Es negative, -3. minus 2, and multiplication this is negative 10 again, and this multiplication with the extra negative is positive 12. Okay, entonces we have 25 minus, minus 13, minus 2, and this is 2. Actually, it's 25 plus 13 because minus times minus negative, minus 4. The answer is 34. Confusing or clear? This is determinant. They want to explain how we are using this to solve the system information. But not today. Not today. Today we continue. Okay, let me try to spend the rest of the time to solving this problem in the GeoGebra. To avoid this algorithm. No. Okay, look. Let's move into GeoGebra. Here. Okay. Switch into this. Okay. Here, over there. You see GeoGebra?
Yep.
Okay. Okay, basically the only thing I want to do, next time we continue determinant, more complicated, and the rule for solving the system is basically you edit this determinant is 1, 1, negative 2, negative 2, 4, negative 1, negative 3, 5. It's important, guys, when you are doing this, you are doing slow down, because you understand if you make a mistake, you change one number. Frequently I did that. I change, so I don't get the answer. Wow, so I frustrate. No, slow down. You select this. You create a matrix. This matrix is M6. Is the name of this matrix M6. And you in the cast you put determinant. Look, determinant. Wow, determinant. You don't finish the typing determinant of what? Of the matrix M6. Press enter. Boom. 34. Do you see that? Do you see that?
Yes.
Okay. Okay, guys, then it's too much for one day, no? Now let me stop sharing. Do you see my face now?
Now it is.
Yes.
Okay. Okay, so now don't worry, but I would like you practice a little bit with the GeoGebra. You open, you watching the video, okay, and you try to do by yourself. I know that it's not hard, but you need to get the skill, no, to edit the matrix. Basically, is reduce echelon form, inverse matrix, multiplication of the matrix. So any operation with the matrix, and the last part is determinant. Okay, I don't finish. Let's continue next class. Okay, guys. Bye bye. Have a nice day. Enjoy your weekend. Okay. I am leaving.
Have a good day, Professor.
You too.
Yes, Professor.